Alright, geometry students, we're going to talk about interior angles of a polygon today, and this video is just going to be a real simple, straightforward video on deriving the equation of that formula. And let's just use some really basic things that we already know. So we start with a triangle. We know a triangle has three sides. Has three sides, and it takes one triangle to make that up, and we know that the number of degrees in that triangle is 180. We did that a long time ago. Different ways to prove that, but we'll leave that alone. Now let's think about here taking this quadrilateral. How can we go about taking this, in this case a parallelogram, and cutting it into triangles, because we know a lot about triangles. Heck, half the year is spent on triangles in geometry, it feels like. So if I were to draw a diagonal into this figure, I've now broken it into triangles. And right here, some of you are going to probably pause and say, well, wait, Mr. O, there's another diagonal in that figure. And you could go from the top right corner to the bottom left if that were your first diagonal, but we're not going to do that because our diagonals cannot cross, because what we're looking for here are the interior angles, and we want those angles created by the sides of the polygon. And if we had angles crossing in the middle, we'd have to deal with taking those out as well. So let's not do that. Let's just simply make triangles using the exterior sides and diagonals without crossing. So here we've got a four-sided quadrilateral. There are two triangles, and if we do that math, that would be 360 degrees, because 2 times 180. Pentagon. Now we're going to start with one vertex and draw the diagonals from that vertex to another spot. Again, I apologize for my lines. Doing this with a mouse is not nice. And if we look at this as best I could, 1, 2, 3 triangles. And if we do 3 times 180, we end up with 540 degrees. So let's just go through, and I'm going to do it real fast here just to fill them in, just so we can get down to the point where we are going through this. So now there are 4 triangles. You should see a pattern developing here. If I do the heptagon, 7 sides or 7 angles, whichever way you wish to describe that. That one has 5. And then our good old friend, the stop sign, the octagon, has 6 triangles. 1, 2, 3, 4, 5, 6. Poorly done, I'm sorry. But it's just to get the point across. Now we have 4 times 180, which is 720. 5 times 180 is 900. And finally, the 6 times 180 is 1080. So let's look for the pattern. An n-gon. And I know you're going to say that's weird, Mr. O. Honestly, once we get beyond a certain point, we no longer deal with the Greek prefixes on figuring out what the name of the figure is. Even though I know icasa means 20, and I can call it an icosagon, most textbooks are going to refer to it as a 20gon. So anyway, we have n number of sides. So noticing this pattern, that's the n. Now, how did we get from n to the number of triangles? Well, I went from 3 to 1, 4 to 2, 5 to 3, 6 to 4. There's a pattern there. Every time I had the number of sides or the number of angles, all I did was subtract 2. So I've got n minus 2. And now to figure out the total number of interior angles, or the sum of the interior angles of a triangle, I have to take that n minus 2 and then multiply it by the number of degrees in a triangle, because it's the number of triangles times the number of degrees. So it's n minus 2 times 180. And there's our formula. That's the formula you've got to use for figuring out the number of angles inside of a polygon. And that's it. So there's the how we derive the formula. And I'll probably come back with a couple more videos later on. But this one I just wanted to throw out there just so you understand where the formula comes from, and just in order to figure it out. So if we had like a 12-gon, which is called a dodecahedron, you'd take your 12 and you'd plug it in for n. So 12 minus 2 is 10. 10 times 180 is 1,800. So the number of degrees in a 12-gon would be 1,800 degrees. But anyway, good luck with that, guys, and I'll come back with another video with a slightly more complex twist on this.